All right, our next lesson is called function modeling. It's not something we really covered in my class, but I'm going to show you how to do it real quickly. And it's something that's going to show up in free response question number 2. So basically, this is how it's going to come down in free response question number 2. They're going to give you a real life scenario. It's going to be in paragraph form. You're going to have to read the details. They're also going to tell you a function formula that best models the scenario. That could be a linear, it could be a quadratic, a cubic, it could be a logarithmic, it could be exponential, it could be any type of function, and they're giving you an equation that represents that function. For instance, if they give you y equals mx plus b, they're saying that a line best represents it. If they tell you that it's y equals ax squared plus bx plus c, that's a polynomial, right? They're telling you that that's the function that best represents it. Or they might tell you that it's exponential, okay? So what you have to do in FRQ number 2 is 2 steps. You have to create a system of equations to help you find the coefficients of the model. And then you're supposed to solve the system of equations. So having 2 unknown coefficients require 2 equations. If you have 2 unknowns, you have to have 2 equations. That's akin to saying, in order to draw a model, I need 2 points to make a line, for instance. Or possibly I need 2 points to create an exponential model, right? That's what we're saying here. If there are 3 unknown coefficients, that requires 3 equations. That means to build the model, I need 3 points, something like that. Like if I have those 3 points and they tell me it's quadratic, I know my quadratic curve is going to go through those 3 points. Doing examples will clearly show what this is all about. So example number 1 is going to be a 2-variable system of equations. That means we're going to have 2 unknowns. And looking here, B and R are my unknowns. And since I have 2 unknown values, I have to have 2 equations. They're giving me a real-life scenario here. There's a plumber who works on large commercial and industrial jobs. Okay, that means this plumber is expensive. He's doing a lot of important work for companies. Just showing up, it says just to show up, he charges a $150 fee. Okay, that will be important later to develop the system of equations. After that, he charges an hourly rate for the time he spends working on site. So he shows up, $150 already, and there's some sort of like price he has per hour, and he didn't tell us what it was. For example, at one recent job, he charged a company $1,123.42 for a 9.5 hour work job. Just by reading it, I already see 2 points. I see the beginning and the end. I see a cost if he just shows up, and I'm seeing a cost of him being there for 9.5 hours. Now let's read what they're telling us. We can model the total cost of his services using the formula I of t equals b plus rt. Now this is just a fancy way of writing y equals mx plus b or y equals b plus mx, where t is the hours worked and I of t is the amount of money he charges for his service. I think it's I because he's going to make what's called an invoice. An invoice is a fancy way of saying bill. So use the given scenario to write 2 equations that can be used to find the values of b and r. So there's 2 variables here. There's time and money. So let's go to each one. So here, my money is $150. And that's when my time is 0. So I already found 1 point on my graph. And then over here, I have, and I'll highlight it so I make it stick out, I have this amount of money for that amount of time, right? So let me write a side note down here. For time 9.5, my money, my invoice is going to be $1,123.42. So how do I write a system of equations? Well, I'm going to plug these numbers into the equation and see what I get. And this is my equation. So I have I of 0, right? That's going to give me a $150 bill. And we're going to plug that 0 into that formula. Well, I don't know B, I don't know R, but I know 0 is my time, right? Okay, and then we're going to plug in I of 9.5. And that should come out to be 1123.42. And that means B plus R times 9.5. Okay, so let me summarize my answer here. I have this equation. I have 150 equals B plus R times 0. And I have 1123.42 equals B plus R times 9.5. That's my system of equations. I have two unknowns. I don't know B and R, but I have two equations that can help me solve it. I can simplify it by saying, hey, R times 0 is going to cancel out. So if I wanted to answer the question like this, B equals 150 and 1123.42 equals B plus, and normally we like to put coefficients in front of numbers, so we're going to write it like that. So this is going to be my final answer to get the point. Now, how do I find it? Well, I'm not going to teach all the algebraic skills to solve systems of equations because I don't want to spend weeks on it. So we're going to use Desmos. The most efficient way of doing it is to create a table. You can create a table by hitting the plus sign and saying table, or you can type the word table in Desmos like this. Okay? I actually want to change the names. I don't want X and Y. I want to use the original names. So I'm going to call this variable time, and I'm going to call this variable the money, capital I, right? And I know for $0, for 0 hours just showing up, I have to pay $150. And I know that at 9.5 hours, I have to pay a bill of $123.42. Let's zoom out and see if these numbers ended up getting on my graph. Yep, I see my 0, 150. And I zoomed out so much that I need to change my view to get better view here, right? I don't need to see more than 10 hours, and I don't need to see negative time, right? I'm going to label this axis the time axis. And my invoices are not going to be less than $0, and they're not going to be over $1,500, right? So I want to see my graph better. Okay, apparently, yeah, there's the points. There's the 2 points that I put on the table. While I'm here, I'm just going to say, friends, don't forget about this gear, this fringe, I mean to say. This can help us look at the graph better and help us understand these things. So now we're going to create a regression between those 2 points. You might be thinking, well, Mr. Cherrims, we know it's linear. And I'm just going to go click on that, and it's going to create my linear regression. That's fine, but I want to show you how to make your own regression. Maybe there's a formula that you want to use instead. Okay, so to do it, you have to use the names as they are written up here in that table. I have one. And instead of using an equal sign, you use the tilde, this little curvy equal sign. That tells Desmos that you're about to do a regression. And you can use the names of what was given to you, B and R, and then instead of writing T, I'm going to have to copy and paste that here. And what that tells Desmos is, hey, use the values in that table. This is the X values of that table, and that's the Y values of that table. And boom, it's giving me what the B and R are. Of course, it was obvious that B was 150. And that the rate the plumber is charging is 102.465. So this is one of the few times that you can actually use the graphing technology as a justification for finding your answers. According to the regression in Desmos, B is 150 and the rate was 102.465. You might be thinking, Mr. Cherry Holmes, dollars can't go to the thousands place. We have pennies. How can you have, 1/2 of a penny here? Well, actually, that's not true. If you actually look at gas prices actually charge you in the thousandths of a penny, right? So on the AP exam, if you need the round, you better have 3 numbers after that decimal point. Unless they're zeros, you don't need them. But if they're not zeros, you better have 3 numbers after that decimal point. All right, I would like to reflect on the process. We got our scenario. We had 2 points, 2 data points. They gave us a formula. We plugged in the data points into the formula, created a system of equations where I had 2 unknowns and 2 equations. And then I used a regression in Desmos to find it. All right, let's do another example here. Okay, another real-life scenario. A missile is launched from the top of a cliff. So here's a cliff, and I'm going, boom, and it hits the ground, right? Right here. Let's say it hits the ground right there. The height of the rocket, how high it is a function modeled by this formula. Okay, notice this is what's called a vertex form of quadratic formula. X represents the horizontal distance. So actually we're using traditional X, and we're using not Y, we're calling the height, we're calling it H. Okay, so we have a graph of X and H. And they gave us the 3 points, and this one's really nice because they gave us a table, right? And so we just got to write the 3 equations using the table. And they gave us the formula. So let's start off with x equals 0. So h of 0 is going to be capital A. I don't know it, so I rewrite it. 0 minus b, and then squared, plus c. Okay? So, and that should equal 42, right? So this says if I plug in 0 into the rule for h, it's going to give me 42. My next example, h of 2. Okay, I don't know a, but now my t value is 2, my x value, and that should equal 48. And then h of 7, a, 7 minus b squared plus c, should give us 0. Okay, there's my 3 equations. Let's finalize the answer. Okay, 0 minus b, well, that's negative b. So we're going to have a times negative b squared plus c equals 42. That's our first equation. I have 3 unknowns, 1 equation down. I have a 2 minus b squared plus c equals 48. And then I have a 7 minus b squared plus c equals 0. Good news, I don't have to solve it. I just got to use a regression. But here I had my 3 unknowns, a, b, c, and 3 equations. That gets me 1 point. So let's figure out what a, b, and c are. So here are my 3 points. Those are the 3 points that help me create the 3 equations. I only see 1 point on the graph. That's because I got to change my window. Remember to use the wrench. Our x values, I like to see anything from 0 to 7. And my y values, the lowest it goes is 0. The highest it goes apparently is 48. Right? And I'm going to zoom out a little bit. And there you can see my missile. My missile goes up. And then eventually my missile hits the ground right here. Now if you're thinking, oh, this is quadratic, I'm just going to use a quadratic regression. And you go, oh, Mr. Cherry Holmes, there's my A, B, and C. Nope. This is standard form. They gave you the form they wanted. Let's put the form that they wanted in. They wanted h of 1 as a function of capital A and our variable x of 1 minus b squared plus c. Those are the a, b, and c for the regression in the form that they wanted it. So, according to Desmos regression, A equals negative 1.8, B is 1.833, and C was 48.05.